All right. Welcome to another episode of Protocol Explorer. Today I'm joined by Youssef from Superfluid. Youssef, can you introduce yourself a little bit? Tell us what you do.
Hi, Rahat. Thank you for having me today. So I work at Superfluid. I am a developer relations lead at Superfluid. Um, Superfluid, for those of you who are maybe not very familiar or a little bit familiar with, is a money streaming protocol. We allow you to transfer money on a second by second basis. So I invite you all to kind of go on our website and check out our app and things like that. There are a lot of cool applications for it, but basically, one of the main features and special things about Superfluid is that instead of sending just instant transfers of money, for example, if you want to send money every month, for whatever reason, you can send an open-ended stream using our token standard called Super Tokens. We will discuss a lot of this today, but yeah, very excited to be here, and thank you for having me.
Awesome. And folks, if you're tuning in, if you have questions about anything that we covered throughout, definitely just leave them in the comments and we'll try to address them as they come up. Cool. You want to tell us just a little bit about what we're going to be going over today?
Absolutely. So before I go to the contract that and the use case that I was thinking we should go through today, I will go a little bit over our new feature. So I'll share my screen for that. I'm just going to show a page of the docs. So you can check our docs on docs.superfluid.finance. And Superfluid is a token centric protocol. So everything is around super tokens. So if you look at the structure itself of the protocol, how it is, even in the docs, we talk about super tokens, we talk about money streaming, and we talk about distribution. So money streaming is one feature, let's say, of super tokens and of Superfluid. Another one that we just launched is distributions, and specifically distribution pools. So what distribution pools allow you to do is scale one to many money transfers, be it instant transfers or money streaming transfers. And today, for example, if you want to send a simple transfer to multiple wallets, you would have to either send them an ERC20 transfer for each wallet manually, or you can do it using some batch transaction solutions like Disperse app or other solutions. The way Superfluid handles this problem is and for it to be infinitely scalable without additional transactions is we create these distribution pools. So you can create a pool and you can assign shares to each members of the pool, and basically you can send either instant transfers to that pool, and then each member sees their balance updated automatically, or you can send a money stream to that pool, and each member of the pool gets as much percentage of that stream as they have shares of the pool. So to go a little bit more over, how the pools work according to what we call member units. So these member units are what we call the shares in the pool, and basically the floor rate per unit is calculated. So say a share has 100 units, for example, with 10 members, each member has 10 units. So we calculate the floor rate per unit, and then we calculate the floor rates per member, which is basically the number of units times the floor rates per unit. Um, until here, is everything clear, Rahat? Are there any questions in the chat about this?
Looks like we're good so far. Yeah, I think makes sense to me, at least at the moment.
Sounds good. And so the best way to interact with super tokens on chain is the super token v1 library. It's a library that has all the functions, including for money streaming and for distributions. And here in the docs, you can see some of the most important functions. Creating a pool, for example, update member units, and we will go through a lot of these. Um, we will go through a lot of these functions during our session today. But basically, all you need to do for you to create a distribution is to create a pool. And one thing that's cool really about the pool is that the member units could be um, deployed as an ERC20, and they can be transferable. So the shares that you have in the pool, if you transfer them to someone else, that other wallet starts receiving the stream instead of the initial wallet that was attributed the units. So that's a cool functionality. You can also deactivate that and make it unavailable. And also anyone can distribute to the pool. So you can make it so anybody can distribute to that pool. You can also make it that only the admin of the pool can distribute. And one more step for the user, for them to get the stream and start seeing it on their balance. So once a stream is started and is pushed to a pool, um, that starts adding up to the user's balance in the background, but it doesn't show when you call the function, the famous function balance of ERC20. So you would need to connect to the pool. It's kind of like an agreement for you to say, okay, I'm connecting to this pool. I want to start receiving streams from this pool. So this is what this function is for. Disconnect to the pool. That's simple. Distribute to the pool is distributing just simple token transfers. And here we have an example usage, but I think what's better is maybe if we go through the template that I shared with you. The goal today is to go through an NFT that has a revenue sharing functionality to it. So with every mint that will happen, that money of the mint is going to be streamed to a pool which shares the money back to the minters. And so basically this is just to showcase the capabilities. There's no, the money is basically the same money as almost that you mint with is going back um, to your wallet through a stream, just a little bit slower, right? But it's just to showcase the capabilities, and you can scale that to different use cases. And I will share some alpha, I guess, about that later on during um, our coding session. But yeah.
Nice. I had a quick question there. So you'd mentioned that like if we do like a balance of for the token, then you wouldn't be able to like see the current balance as of yet. So like when you're streaming and you have this pool created, it's like I'm just trying to like have the mental model in my head.
Yep.
Like the pool is kind of like allocated to you, right? So like you're kind of like receiving funds in that pool, and then you can claim
hmm
the funds from there. Is that the good way to look at it? Or
A good way to look at it is anybody can create a pool and assign you units in that pool and start
okay.
streaming money to you. For you to see that on your balance, you need to call a function called connect to the pool. So let's say you don't want to see that. You don't, it's not something that you would like to have on your balance. And so it only makes sense that you would just connect to the pool to say, okay,
Mhm.
I want this to show in my balance. And that's what's really cool about Superfluid is that your balance updates every block because of the money streaming capability. So that's another thing also in Explorers, for example, sometimes the balance of a super token could be off because the Explorers only pick up transfer events.
Mhm.
But on MetaMask, I believe they fetch your balance every time you open the wallet, so you can see the actual real balance with every block or every time you open your wallet.
Got it. Makes sense. Cool. Awesome. So you did share GitHub with me before this call. I will also once we edit the video and put it up on YouTube, this will be available in the description. But this is the GitHub below, and I'll share my screen now, so you can walk me through how we can start building this. Okay. Cool.
Okay, cool. Yeah, so I just what I put here is just a few imports to make it easy for you, and also if you open the foundry.toml, you will see that there's a few redirects, remappings, so that just to make sure that the imports are working well. All you would have to do here is, I think, first forge install, so
Yeah.
that we install OpenZeppelin and Superfluid libraries.
I think I did that, but yeah, I did that.
Okay, great. Now in the smart contract, so if you go to smart contract, exactly. So the smart contracts inherits and ERC 721.
Mhm.
And so we will try to override. Let me open one file that I have here. Okay, yeah, we will try to override the mint function, right?
Okay.
In the or at least build upon it. I think we can just either, yeah, we don't need to override it. We will just use it, right?
Yeah.
So we can create a function maybe called, I don't know, distributions mint or dmint or something.
Distribution mint or
Dmint, let's call it dmint. And that function maybe could take the address too, where are we going to mint it to, and also the token ID.
address too. Um, and a uint.
Yeah.
Cool.
Okay, cool. So this is the mint function. What do we need in the mint function if we're just like kind of thinking about it? Well, at some point we will need to use the internal mint function of ERC 721, right? Like, so dash mint to ID, right? So
Mhm.
at least we can have that. Um, Before we mint, maybe we want, so maybe, maybe this function is dash dmint, so right, like this is a private one, and then we will have another public one, payable, right?
Cool.
And so what do we need to do? We take, I guess we can take the token price, right? So maybe we want to define a variable token price that we set. Maybe it could be, global variable. But yeah, here, yeah.
Price.
So this is going to be a mint, for example, with the native token, right? We would need to wrap that to make it a super token. So maybe what we do is we we declare the native token first. I think I already imported ISETH. So ISETH exactly is basically a super native token interface. So if you can create a new ISETH and call it um, native token, we will assign an address to it later on in the constructor. But there's a reason why I started with the mints, just to kind of make sure that we're core focused on the functionality.
Gotcha. Cool. Um, so so we want
IS
to use
ISETH,
okay.
maybe declare like ISETH native token or public native token, or just a new variable ISETH.
Okay.
Um,
And this is
oh,
going to be
an interface. So you would put ISETH in capital letters,
okay.
right? And then make it public, I guess. Make everything public, all variables public, just like easy for us to query later. Um, Public native token, or maybe native super token, to make sure that we make the difference between exactly. So this is going to be our native super token, right? Okay, let's create a constructor so that things are clear to people after. Um, Maybe create it after you declare the variables constructor. Okay, cool. So the constructor would take one of the things. First of all, the constructor is also an ERC 721 constructor. So after the second parenthesis of the constructor, you would add ERC 721, and then yeah, okay. So back to the constructor variables. Cool. Now you would put maybe like string memory name, right? Because that's the name of the NFT. String memory symbol, and then iCeth in the same iCeth dash native token, sorry, or native super token. iCeth
I
dash
see.
space dash no space like yeah no yeah it's just like a new variable that we will
Mhm.
put inside the I guess. And what else do we need also to declare token price? So I think should the
The
token
UN.
price, yeah, exactly. You went dash token price.
Let me format this better.
Yeah.
Formatting is not working nicely. Okay.
Okay, cool. For now, let's keep it that way. Now, the ERC721 will take name and symbol. So that's where we will need the name and symbol to feed them to the ERC721. Okay. And inside the constructor, we would maybe assign token price to token price and native token to native token, right? You put token, does token exist? It's rather token price.
Cool.
The first one is token price, not token.
Oh, token price.
Yeah.
Yeah.
Okay, cool. Now that we have both, we can go back to our mint function. And what we want it to do is to wrap our native coin into a native super token. And for that, we will interact with. So one thing that you would need to add is let me send in this in the chat. So it's easy using super token v1 library as iCeth, so that we can interact. So add that at first before token price. Exactly. So this would allow us to interact with native token directly through the super token v1 library. We'll see how we do it. So back to the mint function. Before minting, what we would do is we would write a native super token dot upgrade by ETH. Upgrade by ETH. Exactly like that. Yeah, exactly. And it would take it's a payable function, so you would put a bracket, and value would be token price. You put value. Yeah, I know that works. Maybe like a bracket, not a parenthesis.
Oh, a bracket.
Yeah. Just as you would do with the payable function. Bracket value. No, oh, okay, maybe. Well, the other ones, I'm sorry, my English is
Oh,
not my
sorry.
first language, so maybe that's not called a bracket. What is it
Oh,
called?
I usually call those curly braces. I'm sorry.
Okay, that's good. And then inside it would be value token price, value dot, so value to 2 points token price. Yeah,
Value dot token price.
No, not dot. The 2 points that are vertical.
Oh,
Yeah, exactly. And then after the bracket, you would put two parentheses and then points comma to close the line.
I'm a little confused.
This is a payable function. So what you do is you call upgrade by ETH,
Okay.
and you put the value that is like token price. So we're gonna wrap the native coin. So wrapping the native coin means that it is a payable function, right?
Okay.
And yeah, so now after that, once we put native super token upgrade by ETH. So we interacted with the native super token contract that
Okay.
exists on chain already, on every chain that Superfluid framework is deployed on. And we are wrapping the native coin to make it a super token. So now our smart contract holds, the same amount of the mint for each mint in super tokens, right?
Okay.
Um, that's exactly what that line does. It just wraps the native coin into
Got it.
a super token. So now we have our super token. What we want to do with it is, um, maybe we want to stream that amount over a month, right? For example. And so to do that, let's first of all calculate um, let's calculate the flow rate that we would want to have. So in Superfluid, flow rates work in Wei per second. So
Mhm.
we can say, for example, you want to send me $1 per month. You would need to calculate that on a Wei per second basis. And so in that case, what do we want? For example, what would be the duration of the flow that we want to keep, like say a month, okay?
Mhm.
So what we would do is let's um, calculate flow rate. Let's do, I think I already have a line somewhere here. Actually, let's make the token price, let's make it UNT 96, just so that it would be a lot easier for us later. And let me send you this line. Exactly, because flow rates are int 96. Okay, so this line that I sent you in the chat um, calculates what it does. If you can copy paste it, and then I can explain it. Maybe after the native super token upgrade. Yeah, and native token does not exist, so maybe native super token instead of native token in that line. But it doesn't matter. I'll just explain the line. So what the line does is that basically we take the balance of the contract and we divide it by our flow duration. So every time anyone mints a new NFT, so for example, I don't know, the smart contract has the mint is 0.1 ETH, and the smart contract already has something like one wrapped ETH super
Mhm.
token that is already streaming. If
Okay.
someone else comes in and mints a new NFT, then basically we take the full balance after the wrap-in, and we divide it by like a flow duration, which is a month, and we start streaming that, so that every time anyone mints, there's another month of streaming to all the people who are in the pool. So that's what it does. It just calculates the flow rates that we would like to have. So that's the flow rates that we will update with. You can see there that flow duration is missing, and then also you might start thinking, okay, we have a flow rate, but how are we going to even distribute it to people? We don't have a
Right.
pool that is created, right? And so let's do that. Let's create a pool. Let's first create a pool. So one thing is like declare maybe a public variable, I superfluid pool, um, pool. Let's name it pool.
Okay. So this would be
I superfluid
with
pool.
this.
Yeah.
Okay.
Okay. The pool takes a pool config. Now in the docs, you can actually find what the config looks like. Let me send it here. Just for ease of use, let's create another variable. It could be private. This one that is a pool config. So pool config, it would be pool config. Yeah, uh, yeah. So that's, yeah. Remove the struct, I guess. Right, and then name the pool config to, I don't know, pool config in a lowercase something. Yeah. exactly. And then that would be maybe what we assign to it is so assign to it um, yeah. So you would do equals, right? Like to assign to it. Exactly. And then you would do something like, I think, pool config open parenthesis, right? That's how it I think, yeah, that's how it is. Pool config open parenthesis. Exactly, yeah. Where the first one, no, well, p would need to be uppercase in this one. Yeah. And then you open parenthesis. Exactly. And in there you would put um yeah, transferability for unit owners. Exactly. So inside the pool config, yep. And then you remove the bool because you don't need to declare it now. It knows the pool config, right? Yeah, I don't know if that's the way you declare a struct. I think it's something like this. Let me
So
put
this
it in
should
the
be a
chat.
struct. I
Yeah,
thought we
it
were
is.
removing the
No, it
struct.
is. It is a struct.
Okay.
Yeah. Sorry for the confusion. Oh,
I
this is not
think
the way.
it was.
I think it's something like this. Right. And
So within the parentheses, we pass a struct.
yeah, exactly. So like this, right? Within the parentheses, you have this exactly, and then for each one line, you will take these, like, so you would put something like, okay,
Sorry.
not worried. Something like this. Yep, I sent you the last one. Yeah, exactly like that, and then remove the second bool. Yeah, and then so for transferability for units owner, you put then, yeah, true. For example, you can put for the other one also true. So basically, what this pool config does is that it says it assigns whether or not we want to make the units transferable in the pool. Like, do we want them to be ERC20 tokens transferable, or and do we want to allow distribution to the pool from any address? So for this experiment, we put both of them true. Okay, cool. Now we can go to the constructor and create the pool.
Okay.
And so for that, we would do pool equals super token v1 library dot create pool. Open parentheses for and then we need to specify the token and the pool admin and the pool config. So the token would be super native token, native super token, right?
Native
Sorry.
token. Yeah.
Yeah. And then the address would be address this, which is the same as it would be the pool admin. And um, and then we also need to specify pool config, so we put pool config. No, just pool config. Yeah, we've already created it. Yeah, exactly. And that's it. So now we have a pool that's created.
Okay. So this is just going to create the pool of this
Exactly.
specific token.
For this specific token, and it's a pool that's managed by this smart contract. It's gonna be the admin, right?
Okay.
And for that pool, we will be assigning units. And so now that we have now we need also to specify the flow duration. So that's something that maybe we can add to the variables of the constructor. if create a global variable, call it flow duration, make it public so that we can query it later if we need it. It would be, I think, what would it be? This one, yeah, a uint 96 as well.
Okay. And this would be the flow duration.
Yeah. Maybe, yeah, there, yeah. Exactly. And yeah, from there, maybe you can pass it as also a variable in the constructor, dash uint 96 dash flow duration 96. Yeah, there's a little typo in the flow duration variable entry, uint 96 instead of 90s.
Oh.
Okay, cool. Well, now that we have this, if you go back to the mint function, you see that the flow rate, now we can calculate the flow rate, right?
Mm-hmm.
And then, so the next line, what we will do is that we will update member units. So next line after the new flow rates that's been calculated. Yeah, we will update member units. So how we update member units? We again, Superfluid is the token-centric protocol. Always use the Superfluid v1 library. Where we'll and in this case we just do native token dot update member units.
So native token.
Yeah, native super token dot update member units. Exactly, and you open the and it would take the pool. It would take the address of the member that we want to update. So that would be the address 2, right? And it would take how many member units we want to assign. So let's assign 1 for each NFT mint. Let's assign 1, right? And then once that's done, so now what we have, we calculated the new flow rates that we want to send to the pool. We gave to this new minter, we gave them a new unit in the pool, so they have a unit in the pool. Now we want to distribute this new flow to the pool, right?
Mm-hmm.
And for that, we'll do native token dot distribute flow. Okay. Distribute flow, in the distribute flow we would do address this, so it takes from, to, and the flow rate. So address this to to the pool, so we were distributing to the pool, and then the flow rate is the new flow rate, right? That's it. Now we have our internal function. Let's create our external function. Function dmint yeah, so let's
address on uint as well.
I don't think it needs to take it because we will make it so the message sender is getting the one. One thing we would do is create a public variable, call it maybe token to mint, just to increment, so that we know which token ID we're going to mint. No, not in the constructor, just a public variable.
Okay.
Yeah, it would be a uint, a normal uint, a uint 256. I think. Yeah.
This is for token ID, right?
Exactly. Token ID, or token ID sounds good. Okay, let's leave it that way. Okay, so what you would do in the dmint function, maybe require that message value is equal to token price. Return some message. You're too poor or something.
Please, I don't know.
Not
I
enough.
always hate doing this. What do I say? Um,
Please send more native token or something, more ETH.
invalid token, invalid amount. I don't know.
Yeah. Okay. And what we want to do is then that would be it. Then we would call the GDA the dash dmint, right? Dash dmint, message sender, and then token ID. Exactly. And then in the next line, you would increment token ID.
We want to. Should we increment it first, or
You, I don't see any problem with doing it before or after, but I think if you increment it first, the first token is not going to be 0. The first token is going to be 1. That's the
okay?
difference, I guess.
Yeah.
Yeah.
Okay.
And that's it. So we don't emit any events here. Maybe we could emit, an event here at the demint if we want.
Yeah. I'll just add those to do.
Yeah. So as far as I'm concerned, I think we're good to go.
I think there's something wrong with the constructor.
Oh.
Oh.
Yeah. And maybe we could go to test just to write some very, basic test that we can run.
I'm just adding all my semicolons.
Yeah. This is only 2, actually. You put 3. You only need 2.
Oh. Upgrade by ETH not found or not visible.
Oh, wait. This is interesting. Upgrade by ETH. ETH is all in cap in yeah. Yep, that should be fine then. Message value. Oh yeah, make it payable. Yeah, demint, you need to make it payable.
I think we're good now.
We're good. Okay. If you go to the test file. Okay, so I already have quite a few imports. So what we do here is we import. Change the contracts because I had another contract. Maybe we call it distributions NFTs. So exactly. And same inside the code, maybe change the name of the contract, call it distribution NFTs. Yeah. The test as well. Sorry for forgetting that.
Good.
And the public variable also name it, distribution contract or something. Exactly. That's it. So here we kind of like import a lot of the variables, Superfluid pool and stuff like that. And then in the setup function, if you go down to the setup function of Foundry, what we do here is we deploy the framework. So we deploy Superfluid, that we have, a deployment smart contract that's already there. You create a new Superfluid framework deployer, and then you call dots deploy test framework, and then SF gets you the framework. So the framework is Superfluid, has multiple smart contracts. You can take a deeper look at that if you want in the docs, but basically we just deployed Superfluid on this test chain that is local chain made by Foundry that doesn't necessarily have it. You can also fork a chain that already has Superfluid. So once we've done that, maybe look at the commented texts there. Maybe incomment it. I think it would make sense that we incomment it. Okay. And yeah, the contract name should be changed. The name, what do you want to name it? Maybe name it DNFT or something. Cool. The pool also, because it doesn't recognize it. If we go back to the constructor, what did we have? Did we have, if we go back to our constructor, what did we have? We had, okay, name, symbol, native token contract, a token price, and flow duration. Can we go back to the test and see if it's all good? Okay, it's fine. I think it's fine. Yeah, exactly. So we deployed a native super token. So as you can see there, CETH equals in the line 49. CETH equals SFD.deploy native asset super token. You know, all of these functions already exist, and so that's the one we're going to be using. Maybe to make it a little bit quicker, I can send you a few tests I had here that would make it, I guess, simpler for us to go. This is, let's test the mint, and let's test the, right, hopefully this works. Okay. Yeah, this is testing the mint, and we can also test the member units. Now there will be changes to this function, of course. Oh, okay. Can you automatically format it? Ah, thank God.
Okay, so
okay, and maybe another function I sent you. Yeah, distribution MC doesn't have GDA mint, so it has dmint. If you can change the name of that function, line 66. Okay, I think it's all good. I think it's all good. I think it's all good.
yeah.
What it does, so basically test mint, what it does is just you know, gets the token price, of course, and then what it does, yep, it just, you know, starts prank account one, so it's an account that I'd already funded. So if you look back to the setup function, I'd already, so you can see deal, so this is just funding it with the native coin, right?
Right.
And then that account would demint, and we would make sure that the balance is 1 to see if the mint works. The other thing that we would like to see is if the account gets 1 member unit from the pool, right?
Okay.
And that way, what we do there, the second test is basically you declare the token price, start rank, account 1, mints, and then connect to the pool. So we connect to that pool, as you remember that function I talked about earlier on in the stream. And then we make sure that the units are 1. And so hopefully now if you run forge test, it would work. If it doesn't work, add a flag via here to just try forge test. Let's see what happens. Hopefully.
Compiling, come on.
Yeah, it's probably a lot of compiling happening. Okay.
Okay.
Yeah, via ear. Add that flag. It just basically makes it to optimize, because we're deploying the whole framework, the whole Superfluid framework, and it's a bit, you know, gets stacked too deep.
While this is compiling, we did have a quick question. Does Superfluid SDK work with Solidity 0.8.23?
I don't think the SDK works with Solidity um, 823. As a matter of fact, the SDK is something that we're not necessarily putting a lot of emphasis on maintaining. Really, it's still there in the docs for those of who are already using it. But if you look at the protocol and and the examples and what we are pushing people to use is the forwarder. So to interact with Superfluid from outside the blockchain, we would recommend to use the CFA v1 forwarder and the GDA v1 forwarder that you can find in the docs section technical reference, and there you have all the functions to interact with the protocol from your front end.
Gotcha. Cool. I like to think when. Okay, cool. Amazing.
Oh, sweet, awesome. So these
Tests have
tests,
passed.
both of them are passed. Um, I guess one way to look at pools before I go a little bit further and we check maybe the balance of and the streams and stuff like that. Um, Perhaps you can navigate to. Wait, let me give you a link. It'd be cool to kind of see. So, so this is the Superfluid console, and if we had deployed to testnet and stuff like that, you can actually take a look at a lot of. So it's like a Superfluid Explorer where you can see, for example, this is a wallet. If you navigate to pools, um, the streams, pools. Yeah, here you go down a little bit to see. Okay, so this wallet is not member of any pool, but maybe try this one. No, wait, not no, it's the same one. That one. Sorry. Uh, see. Yep, this one. Let me send you the new link.
This one.
Yeah, go down. See the pools. So here you can actually navigate and see all the pools you are part of, what kind of streams you're getting, how many shares you have in them, and stuff like that. When you're actually deployed. Um, I don't know how much time we still have, but I think one thing to bring up, going back to the alpha that I mentioned earlier on, the same mechanism of the NFT using distribution pools is something that we will use in an NFT mint that we will share this week. And there's going to be some very major news that come in with it. For example, today, if you look at maybe Allo protocol from Gitcoin, Twitter, or our own Twitter, you will find an announcement about quadratic funding with Gitcoin using
Nice.
streaming and using the distributions pool. So every grantee, for every grantee, we create a distribution pool and we assign units, and these units are quadratically increasing according to how many people are voting by donating, right? Um,
Interesting.
and so a lot of these mechanisms are also very cool to explore. Many other ones are coming from Superfluid down the road, and one of them is going to be a little bit more advanced version of what we've done today. That's why I had a lot of bits and pieces of the code that could be
Nice.
reused.
That's really dope. So I had a couple quick questions, I
Yep.
guess, about what we just built. Um, so in this specific case, we're just streaming to one person, right? That's what this one is for. Is that correct?
No, that
Mhm.
means we are so update member units. So every new person that mints
Mhm.
an NFT, they get one more unit,
Ah, okay.
right, in the pool.
That didn't click in my head. Okay.
Exactly. And then you do native super token distribute flow. So you distribute the flow to the pool, and the pool has other people that have minted before. So the earlier you've minted, the more you've minted, the more shares you have of the pool, the more, if there are new streams, you get that money because you have shares in the pool because you've minted before. Yeah.
Got it. Now that makes sense. Cool. Dope. So if you were to do something like, let's say, like with the Gitcoin quadratic funding, whoever mints on that specific um, NFT or whatever, those would be members who would be able to get streamed within that Gitcoin
Yeah,
round.
for the Gitcoin round. So, for example, imagine you have a grantee,
Hmm.
or a number of grantees. They're getting streams donated to them from people
Right.
from the outside, right? But there's also a matching pool in Gitcoin. So the matching pool adds to the grant according to how many people. So the more people stream to you, the more um, streams you get from the matching pool. Now, the matching pool is different than the notion of pool in Superfluid. So not to mix the two, but basically what it does is that we create a Superfluid, distributions pool. We allocate member units to each grantee according to how many votes they got. So the more votes they got, this is how quadratic funding in general works, even in Gitcoin, is that the more votes you get, the more matching you get. Um,
Mm.
so, for example, let's say you have one ETH that you get from one person, or you get zero point 0.1 ETH from 10 people. If you get one
Hmm.
ETH from one person, and you get zero point 0.1 ETH from 10 people, it means that, it's more interesting if you get zero point 0.1 ETH from 10 people to get coin, because it means more people are supporting you.
Right.
And in that case, then the matching pool would give you more money than they would give to other people. In the case of distributions pool, we will attribute more member units to that grantee. The more people are voting, and the more people are actually um, given donating streams.
Gotcha. Gotcha. Okay. That makes a lot of sense now. Thank you for that explanation.
Yeah. And yeah, if anybody is interested or intrigued or want to build using Superfluid distribution pools, feel free to reach out. There are a lot of use cases, and more of them are coming out for you to check and see. And yeah, the possibilities are endless. Basically, this solves the problem of scalability for one to many transfers and also streams, which has been something that a lot of people have been thinking about. So yeah,
Awesome. Yeah. Thank you for this. This is very new to me. So really enjoyed just like learning, a little bit more about Superfluid in general, as well as the um, this new feature you guys have. I'm really excited about what you guys are doing with Gitcoin. That's really cool. Alpha, thank you for sharing that here. Um, and yeah, folks, if you all want to go and start building yourself, I've left the docs kind of like on the screen here. Definitely check that out. Um, Youssef's Twitter is also here on the screen. Make sure you also follow Superfluid HQ as well to get more updates from them on any further alpha that they're putting out.
sounds good. Thanks a lot, Rahat, and definitely enjoyed doing this. And yeah, let's do something again.
Yeah, definitely. Thanks so much, Yusuf.
Cheers. Take care.